Hi everyone, I'm Vishnu Subramaniam, founder of JarvisLabs. In this video, we are going to look at a new model and a workflow called SUPIR, which is used for upscaling the images that you probably have, right? We're going to do three different things. One is generate an image using Olama as prompt generator. We'll upscale the generated image using SUPIR. The second thing is probably take an old image. So that is something from the Popeye, one of my favorite shows while growing up. The third thing is, what if the image sizes are not divisible by 32? Then there is a problem with a particular sampler in the SUPIR workflow. How do we solve it? We're going to look at these three things, right? So let's quickly go and see what a base example of SUPIR does. So if you look at this workflow, so I've already built the workflow so that we don't spend a lot of time building it. So this one is basically how to use the Llama for generating the prompts, which I explained in my earlier video. You can check that in case you have not, right? So the prompt is coming from this group nodes to this image generation. So in the image generation, it's a very basic workflow that you would get probably by saying load default workflow in ComfyUI. So we are choosing a particular model, SDXL. The prompt is coming from the prompt to prompt node. And then we are connecting to the K sampler, and then we are having a typical decode. We are not previewing the image there, but we are previewing it to the next node. So this is where the actual thing happens. So let's say we just run this, right? So there are a bunch of nodes here. We will get to that in a moment. So what is happening primarily is we are generating an image which is of 1024, and we are asking the SUPIR model to upscale this image. So what it's doing is it's adding more clarity to this image and its own understanding. As we can see here, the photo on the right side looks more realistic. We can use the same technique to probably generate. People have been generating 8K resolution. What you can do is you can add a resize node here, upscale the image to 2 times, that's 1024 into 2048, and you get a larger image. You can redo this step again and again, and you get 8K resolution image, right? So that's one thing which is being commonly done, right? In this, we're just using a very simple one, generate an image. Here is the generated image, and then we're upscaling it to the new one, right? This for this to work, you have to install the SUPIR custom node. If you have already installed it, please make sure you have an updated version, because the author has updated it and there is a V2 version of it. The earlier version was one single node, which was a lot of things baked in, right? But in the V2, there was he has split that into a lot of multiple nodes, similar to what I think it's exactly opposite to what IP adapter node went through. So now we have a separate model loader, we have a denoiser, and we have few more nodes, right? So this is what happens exactly when you're upscaling. It's adding more clarity, more details to the image. Like if you see the hair here, there's much more details. The eyebrows looks more detailed, right? And the actual effect of this, or the actual advantage of this workflow, really comes when you're trying to upscale it to something like 8K, right? Which you could be trying once you have this workflow downloaded on your laptop or on your JarvisLabs instance, right? So what we are doing is we are using the same model here. First thing is this model loader, okay? And in the model loader, we have two different things. One is this VOF FP16 and VOQ. I think there is an FP32 and there is an FP16. FP16 are like smaller to download and easier to load, so I prefer using an FP16 model. FP32 may give you a slight clarity difference, but it's almost negligible in most of the cases. But if you want to play, you can play. If you're using a smaller GPU, you can enable this. But I'm running it on a A6000, so which has like 48 gigs, so it's usually not an issue most of the times. But if you are stretching it, it could also become a challenge. But let's say if you have a 12 GB GPU or something, then you can say FP8 unit. The biggest part of the stable diffusion model, which is a unit, then runs in FP8 precision, right? Which will help you run a much larger model or achieve much more scaling, even with a smaller GPU, right? First is we are loading this model. We're choosing which model we want. Then we are connecting the model that we have chosen as part of our base workflow. In this case, I'm using Juggernaut. Then we are connecting the clip VAE, which is very common. Then what we're going to do is the image which we have, we're going to add some noise to it. That's going to be a first stage. right? What we can also do is we can take this denoised image here and let's say preview image, so we get some clarity of what exactly is happening. So it should take few seconds to generate this image. Okay, so the base workflow generated the image. It has to go through here, and then we'll get the preview, right? So we can see that the image has been slightly blurred, right? It's almost not very clear when you zoom in. That's where you will probably realize that. Right. Once you have the denoised image, what we are also doing is we can make some smaller changes to the prompts here. The prompt and the model again are combined, just like control it. It adjusts the latents that or the vector embeddings that are being generated from the prompts, right? The same way we do here. There's also this option of caption, which we can use things like Lava for generating the image captions of a given image and then pass it to this. I tried it out, but I did not find a lot of difference in the output, so I'm not showing that, but it's pretty simple. We already have this thing. If AI node, we can just use Lava instead of, we have used here prompt to prompt. Instead of prompt to prompt, you can choose something called image to prompt. Then what you can do is you can pass the image and take captions from it and then pass that to the captions of your SUPIR node. So you would probably use this if image. So then you can upload the same image here, right? In this case, we are not doing this. You can, these are some of the things you can try it out, right? So now we got image and that's being upscaled. Now let's look at, so the only key difference between a normal workflow and this one, right, is instead of using the normal nodes, we always end up using nodes from SUPIR, like SUPIR model loader. There is a conditioner which combines the embeddings that is being generated from the text and the model weights itself, right? And then there is an encoder which takes the image and converts it into a language which the key sampler understands or the computer or the algorithm understands. Once the algorithm understands, we use a SUPIR decode. So there are two more nodes that we're using. One is color match. So if you don't use color match, what happens is the results that you get may not have the exact colors or similar colors. There can be small variations. If you are doing this for old architectures, I was playing with some of the old architectures like temples, museums, right? Then the upscaled image did not have as much details as what I wish it to be. But when you add a color matcher, then it makes a lot of difference. So that's where I would like. But if you want a little bit of creativity, you don't want it to have the exact output, then you can probably remove the color matcher. Then we're also using the image comparer node. What it's doing is it's taking the original image and the target image, and it lets us to compare them, right? So with this, what we will do is we will go and look at the next example in which we convert one of my favorite Popeye show Popeye image, to an upscaled version of image. This is where I think we can see a lot of improvement in that. So set group no to always. So I think I bypassed the previous one, so we don't need to run it again, right? So this workflow is pretty similar. There's nothing much difference except that we are not taking the image from the image generator, but we are taking an image from the internet or probably some of your older images. And we're not making any changes to the workflow, but I added certain prompts here. Like I said that it's an old cartoon, and there was some noise being added in the image, so I added noise, right? Then generated the image. We can see the details here, how it is. So let's generate it again. And we have a lot of samplers that we should play with. So if you run the style sampler, basically what happens is when you have a larger image and when you have a lower VRAM, so what the sampler is doing is instead of taking the entire image, it's going to break that image into multiple tiles, and then it's going to convert them into embeddings so that the model gets a better view of it, and it also uses lower VRAM, right? But for smaller images, if you have like a higher GPU memory, it always makes sense not to have so many tiles so that the image gets a lot of context from the original image without losing some value, right? So here the image is of a very small resolution. I think if you look at the earlier one, by default it comes with 1024. Here I changed it to 512 because I don't want it to, the image size itself is not 512, right? It's a very small image. So what you can also do is you can want to look at the resolutions of these things. You can say there is a node called get image size. We can use that. And let's say word display int and sorry. Let's get here and say display int and let's try to generate again. Okay, so it's 720/540. So what happens when you try to use a much smaller image? That's something which we'll look at. We will realize that things can fail, particularly with certain samplers. That's something which we'll look. So let's say this, we activated this. So okay, so this one has a solution. So what we will do is let's kind of bypass this again for some time before we get to it. Let's kind of activate this piece group, set grouped always. Let's change the image to Popeye in JPEG. Okay, and let's see if we can break this. I think with the default sample it works. I think we have changed it here, so we may realize that it can break, right? So as we see here, it breaks because the image is supposed to have the height and width are supposed to be divisible by 32. Let's say in this case, I think 480. I think it's divisible by 32. I'm not sure. Then it's divisible by 32, right? What about the other one? 360. I think that will not be 360, right? So we get 11.25. When we get a decimal, it's usually not divisible by 32. And when you're doing the unit, I think that's where the problem comes. SUPIR model will go through the unit architecture and at some point of time it breaks, or particularly when it's doing the tiling, it breaks. It's not while running the unit. Okay. Basically, there are certain math operations which will not happen for certain sizes, height and width, or in this case, height and width dimension. So what we end up doing is we end up adding a resize node and resize the image slightly so that we can never. Okay, so this is what estimate. Actually, what I wanted to do was bypass group nodes. Let's go here. Now let's activate this. Let's see what we are doing here. Group node to always. Okay. So what's happening here is, so we're using the same image as earlier, but we are resizing this image, right? We are trying to, it's not just resizing. What I also want to do is, I want to adjust the height or increase the height. So what does it here? It's 480, 360, right? So let's start with 480, 360. But what we are saying is use interpolation, land source, and keep the ratio same. And is saying it if it's not a multiple of 32, then shrink it to the closest number, right? So it becomes 352. Now we can use the tiled restore EDM sampler and just generate the image. Now we should have our upscaled Popeye, the sailor man, right? I'm not sure how many of you have watched Popeye. So this is a very large model, so it's going to take some time. So what we can do is, before it finishes, let's say I want to make it much bigger, right? Say what you would say. So let's say 480 into 2. That's how much? 480 into 2. 960. All right. So let's make this 960 and 360 into 2. 360 into 2. 720. 720. All right. So once this gets finished, we'll probably run this and make the image much larger. So basically what we're trying to do is we are upscaling the image by not using any technique. Basically, we're just stretching it. Then we are passing it to SUPIR to upscale the image. So what we can also do is we'll just make a small twist to that. We'll take this image, copy it, and then paste it to the input. So we are kind of upscaling the upscaled image, right? So now this is done. So what we'll do is we'll say copy clip space. I'm not sure. I've never done with a compare node. Okay, there is a copy image here. And let's say here, I'll say paste. Yeah, pasted image is that, right? So now let's run this. Hopefully it doesn't fail, right? Now I think since we're asking it to make it almost twice the size of it, it's going to take slightly larger time. Let's wait for a few seconds or probably close to a minute. So while doing this, let's also go to terminal and check how much of our GPU is being utilized. We can say watch NVIDIA-SMI. Okay. We still have a lot of GPU memory. So if you're using like a GPU with 16 GB or 24 GB, that should be enough. I'm not really using all the 48 GB GPU. Okay. It's taking longer.
A few minutes later.
Okay. So after a very long time, this actually got completed. So I had to almost take a small break while making this video. So what happened was the sample tile size was 256, which I changed it for the actual smaller image. But once we wanted to make it big, the tile size was actually too small, which was the reason for the entire model to become too slow. So what I did is I made some changes, 928 and 352. Let's not wait for it to complete because I'm assuming that it's going to take some decent amount of time. Or I think it's stuck at F prompt for some weird reason. I'm not sure why. So what we'll do is, after a very long time, we got the high quality generated image. The reason was we were ending up using a much smaller sampler tile size, like 256 or something, right? So which ended up resulting in a large of tiles, and that's what I think would have made it computationally expensive. So what we can probably try doing is playing with a different tile size and stride size. Let's stick to something like standard. Let's say 512 256. Right. I hope it works now. Yeah, it's working now. As we can see that it's like way faster than what it was earlier. Okay, so now we have a highly upscaled image, which looks probably way better for a black and white, a very old generated image. Okay, so I hope you like this video. We'll be adding this workflow as part of JarvisLabs sooner, probably in the next few days. If you have any doubts or if you're stuck with something, you can join our Discord channel and you can ask questions. Our team will be happy to help you. Hope you like this video. Please hit the like button and subscribe to our channel for more videos. If you want any specific topic, please add it to the comments. We will try making videos on that particular topic. Thank you. See you. Bye-bye.